Good day and welcome to today's webinar. Today's webinar, we're going to be looking at the full backup with the Fronius GEN24 Plus. Firstly, I'd like to introduce you to today's team. I'm Mohammed Sidat. I'm the Technical Sales Advisor for the Southern African region for Fronius South Africa, which is an agency of Fronius International. I'd also like to introduce my colleague, Cyprian Okolo, who is the Technical Sales Advisor for Western Africa, and he operates from Fronius International. And I'd also like to welcome our guest speaker for today, who is Ivan Holdsworth. He is from AfriPlus, and his role is as technical support manager. So AfriPlus is the distribution and service partner of BYD, and they do operate from Cape Town, and they will and do operate throughout the entire sub-Saharan African region. So if you want any queries or if you want to purchase any BYD batteries, please contact Ivan. Having a look at today's agenda, we're going to start off with how the Gen24 won the HTW Energy Storage Inspection. We're then going to have a look at the Gen24 Plus series, some basic information, after which my colleague Cyprian will then run you through the installation of the full backup with the Gen24. And Cyprian will also run you through the commissioning with full backup for the Gen24. After which, Ivan will then run you through the BYD battery range with a focus on the BYD HVS, HVM premium batteries, which as of the moment are the only compatible batteries with the Gen24 Plus inverter series. After which, we'll end with some further information and a little Q&A session. Again, I'd like you all to input any questions you have into the question tab, and my colleagues will try their best to answer all questions before the end of today's webinar. Okay, starting off with the first topic. The Gen24 Plus recently won the HTW Energy Storage Inspection. And basically what happened in this energy storage inspection, it was carried out by a university in Berlin, and they took the most popular hybrid inverters on the market, and they took them and tested them with the BYD battery box. Okay. And it so happens that the Fronius Simo Gen24 Plus 10 kilowatt inverter achieved the top prize for this competition. As you can see, we beat our competitors, and it's a very encouraging sign that with this study, it showed that with the Fronius and the BYD combination, you are able to achieve a 94% overall efficiency. Okay, and this is the overall system efficiency. So it's the efficiency which takes consideration of all the different conversions that happens in the inverter itself. As we always say, if you purchase an inverter which gives you a good efficiency, you will always achieve a maximum yield, and this will again lead to highest self-consumption as well as your fastest return on investment of the system. Okay, so how did the 94% figure be achieved? That was done using the different conversion parts that the inverter has to do. And if you look at the PV to AC conversion, the Gen24 Plus was able to achieve an efficiency of 97.6%. Okay. If you look at the PV to battery conversion, that was 98.2%. And if you look at the AC to battery, that was 96.9%. And if you look at the battery to AC, that was 97.3%. Okay, as you can see, the first one was for PV feed-in. Second one is for PV battery charging. Third one is for AC battery charging. So this is where you take power from the grid and you charge your batteries. And the last one is AC battery discharge. So, this is where you take power from your batteries and feed it to the grid. Okay, so you can see with all these different conversions, we kind of achieved an efficiency of greater than 96% when looking at each conversion individually. Again, all our competitors were tested. And again, it so happens that we, again, achieved one of the highest percentages per each of these conversions. I'm just going to give you an introduction to the Gen24 Plus series. Okay, so the Gen24 Plus series, it's going to come in two variants. The first one is the Primo Gen24 Plus, which is a single phase inverter, and the power classes are from 3 to 6 kilowatts. The second one is the GEN24 Plus inverter. It's a 3-phase inverter, and the power classes are from 3 to 10 kilowatts. With both inverters, they have 2 MPPT trackers, and they have 1 battery input. What's very important to note is that with the GEN24 Plus, each MPPT can take 2 strings, okay, of 600 volts DC, whereas with the GEN24 Plus, MPPT 1 can take 2 strings, and MPPT 2 can only take 1 string. So the GEN24 Plus, it's an extremely reliable basic system, and it can give you an individual energy transition. It can also assist you to reduce energy costs. Also, expansion is possible because with the GEN24 Plus, as you will see later on in the slides, is that you can interface this inverter with a lot of third-party components and also with other components from Fronius. With the GEN24 Plus, you also get the high-quality product and support that Fronius is known for in the market. So, when you buy into a Fronius product, you always can be rest assured that there will be support available. Okay, moving on to energy flow management with the GEN24 Plus, it is compatible with the Fronius smart meter, and in fact, it has to be used with the Fronius smart meter in all installations. You can do load profile analysis again with our Fronius smart meter, so pretty much the same as what you could do with the snap inverters, you can now do with the GEN24 Plus. You can also do load management, and you can also, have a look at the graphs in order to maximize your self-consumption. Okay, moving on, the GEN24 Plus for self-consumption. How can you use the GEN24 Plus in order to, improve the self-consumption of your client? Obviously, you can, install batteries, but if you don't want to install batteries, you can also go with the Fronius Ohm Pilot, which is a hot water generating device from Fronius. So basically what this device will do is that it will take any excess power from your PV system and use that excess power to heat water in a boiler. Okay. And with this sort of solution, you can get a very efficient temporary storage solution, and you can also ensure that you're using surplus energy, which is again very handy if you are in a grid which does not allow you to feed back. So the GEN24 Plus can be used with or without batteries. So if you use the system without batteries, you do not get your full backup. Okay, you'll only get your PV point backup, which is limited to 3 kilowatts. If, however, you do install batteries, you get the full system backup. And the only battery we are compatible with is the BYD Battery Premium HVS and HVM. It's extremely easy to install. You can increase your self-sufficiency in this sort of system. And we can give you a high power up to 9 kilowatts on our 3-phase GEN24 Plus inverter. Okay, just having a very basic look at the battery. So this is how the battery looks, the BYD Premium HVS HVM. It's a lithium iron phosphate technology. It comes with a very modular structure, so it starts from 5.1 kilowatt hours up to 10.2 kilowatt hours per tower. Okay, and per tower with the HVS, you need 2 to 4 modules. So the minimum amount of modules you need with the HVS is 2, and the maximum is 4 modules per tower. So if you look at this tower over here, each light gray block is around about 2.56 kilowatt hours. And then the black box on the top is basically the BMS system. So what's important to note is that each BYD premium tower needs a BMS system. We also then get the HVM, which starts from 11 and goes up to 22.1 kilowatt hours, and that starts from 4 to 8 modules. Okay, so each gray module, as I said earlier on with the HVS, is about 2.6 kilowatt hours, and each gray module is about 2.68 kilowatt hours for the HVM. The advantage of the BYD battery, 2 key advantages, is you can do a ground mount system, and the commissioning is, again, extremely simple. Having a look at recharging the battery in backup mode. Okay, so let's say the grid goes, okay. What's very important to note is that when the grid goes down in such a system, you can recharge the batteries in backup mode using power from the PV modules, okay. What you can also do is you can also AC couple a Fronius snap inverter, such as in this example, I've AC coupled a Fronius snap inverter to a GEN24 Plus. However, please do note when the grid does go down, this GEN24 Plus will increase its frequency to 53 Hertz, and this will automatically cut off any other AC sources in the system. And This AC source could be a Fronius snap inverter. Okay, so please make sure in backup mode, if you are going to go for AC coupling with a grid-tied inverter, only the Gen24 Plus will be operating in backup mode. So with this sort of a setup, you can offer your clients a sort of a percentage backup of the total installed PV system. Okay, I'm just going to have a look at the multi-flow technology in more detail. So with the multi-flow technology, what we can do is that we can take DC, convert it to AC. We can also take DC from the panels and step down or step up that voltage to your battery storage. But we can also take DC from the battery storage and convert it to AC. And we can do all three conversions simultaneously. And again, we can also do the fourth conversion, which is AC from the grid. Okay, that will be converted to DC and then stored in your batteries. As I said earlier on, we can also add another AC source, such as a Fronius snap inverter. Okay, and as I said, with this sort of a setup, you can sort of increase the system size, but not necessarily increasing the backup size. So the Fronius Gen24 Plus provides you an inexpensive backup power, and this is achieved without batteries. Okay, so if you're going to install the system without batteries, you'll only have the PV point available whenever the grid goes down. So if the grid fails, the PV point is activated and you will get single phase backup power of 3 kilowatts. Okay, and this is in the form of a PV point. Okay, so the PV point is a separate outlet on the inverter. Okay, so you don't need any DC disconnection boxes for the PV points, okay, or any grid separation boxes. The reason for this, as I said, is that the PV point has a separate outlet on the inverter. So when the grid goes down, the separate outlet on the inverter gets activated, and you will then get 3 kilowatts single phase being sent to this single output. Only if you have enough irradiation, okay, coming from the sun. So with the PV points, as I said earlier on, it provides an inexpensive ability to achieve basic backup power. Okay, and it's only activated when the grid goes down. It doesn't matter which Fronius Gen24 Plus inverter you purchase, each one will give you a single phase output of 3 kilowatts max. Okay, however, you can get a maximum of 4.1 kilowatts for a very short duration of time, so between 4 to 5 seconds. And that's very handy for starting off any device that has a high startup current, such as maybe a fridge, for example. Another advantage of the PV point is that it allows you for easy installation. Okay, the reason being is that the only additional component you need between the outlet on the inverter and your load is basically a RCB. Okay, that's the only additional component that you do need. You also then get your full system backup, and this is achieved whenever you have batteries installed. Okay, so it's a full system backup. If the grid goes down, and if it's a three-phase inverter, it can give you full three-phase backup with batteries. Okay, what's important to note is that the Gen24 is not a UPS system. Okay, and it was not built to be a UPS system. It was built to be a hybrid inverter, and this is the reason why if the grid goes down, we will have an automatic switchover, which is less than 60 seconds. The reason why we have that switchover time is that when the grid goes down, we need enough time to send signals to the relays, which will be in our grid disconnection box. And these relays need to open or close depending on what sort of relay they are, in order to ensure that we get proper grid isolation. Okay, and this will ensure that we prevent any power from feeding back to the grid. And this is basically the reason why we have that switchover time. With the Gen24 Plus, we have various open interfaces that you can use to communicate with third-party platforms. So with the open interface, you can use it for easy integration with third-party devices. We can also use it to communicate with home automation systems, also for EV charging stations. Okay, and we can also use it to communicate with very power-intensive loads such as heat pumps, air conditioning, etc. So what communication interfaces are on board as standard with the Gen24 Plus? You do get a LAN, okay, as standard. And the LAN is very handy for establishing a hardwire connection between your inverter and your local network. We also have your wireless LAN capability of the Gen24, so you can also connect this inverter, okay, over a wireless network, okay, in order to communicate with SolarWeb. This inverter also has modbus RTU and TCP, so this is very handy when you want to, incorporate any third-party device to communicate with the Gen24 Plus. For example, the BYD battery. So the BYD battery will communicate with the Fronius GEN24 Plus over modbus, okay? And also modbus is also used to communicate with the Fronius smart meter as well. Your digital input-output ports are very handy when you want to send a signal to a relay, okay? And that relay can then be triggered to open or close, which can then trigger a load to either switch on or switch off, which, as I said earlier on, could be very handy if you want to switch on heat pumps or switch off heat pumps, or even if you want to switch on your air conditioning system when a certain power threshold is reached in the day. We then also get your Fronius Solar API, which is the Fronius communication language. And this is the communication language that the inverter will communicate with any other Fronius devices in the system. So with the Gen24 Plus, you can achieve really good system planning. And this is because we have a wide range of power classes available. Okay, so with the Simon Gen24 Plus, it starts from 3 kilowatts and it goes all the way up to 10 kilowatts, three-phase. Okay, we allow for very broad voltage range. So our voltage range can start from as low as 3 modules and build up. Okay, so the maximum DC voltage you can have per string is 1000 volts DC with the Simon Gen24 Plus. And our MPPT voltage range is active between 80 to 800 volts DC. So when you are planning your system, please make sure that you try and plan your strings such that it can fit somewhere in this MPPT voltage range in order to ensure that you get the best system performance. With the Gen24 Plus, you're going to have 2 MPPT inputs. So MPPT input 1 can take 25 amps. So basically, you can take 2 strings of 1000 volts DC each, whereas MPPT 2 can also only take 12.5 amps, and it can only take 1 string of 1000 volts DC. Okay, so in total with the Simon Gen24 Plus, you can have 3 strings of 1000 volts DC. Your battery input is 22 amps. Okay, with the Gen24 Plus, you can oversize it to 150%. So basically, if I purchase a 10 kilowatt Simon Gen24 Plus inverter, I can put 15 kilowatts worth of PV panels. What it will ensure is that it will ensure that you can achieve a higher rate of production or a higher value of production throughout the day. Okay, then moving on, with the Gen24 Plus, each Gen24 Plus comes with the Dynamic Peak Manager, and the Dynamic Peak Manager really allows you to, install the system where you have a lot of partial shading happening. So what the Dynamic Peak Manager is, it's an integrated optimizer that is based on a software level that will send instructions to the hardware that's incorporated in the Fronius Gen24 Plus in order to change the voltage and current levels that are coming from the panels. And this will ensure that we can achieve the best power operating point throughout the day. And this will assist you in combating system derating, which usually happens whenever you have partial shading on your panels. With the Gen24 Plus series, you also get, the active cooling technology, and this can give your system a longer lifespan. Okay, so what we use is that we use a fan in our inverter. Okay, so we use a combination of a fan that is regulated. Okay, and we also use a heatsink. So the heatsink lies directly beneath the fan, and the heatsink and the fan in combination ensures that we can operate in a really wide range of operating temperatures before system derating starts to happen. And again, this will ensure that you get more yield, and it also ensures that you get more flexible and easier installation as well. Okay, before I hand over to my colleague Cyprian, I just would like to launch a poll. I really appreciate if everybody could share their inputs. So So the question is, if you have to install a 5 kilowatt Primer Gen24 Plus for a residential user, what BYD HVS or HVM battery storage system would you propose? Okay, so you could propose the HVS 5.1 kilowatt hours. You could propose the HVS 7.7 kilowatt hour battery. You could propose two HVS 5.1 kilowatt hour battery. So if you do that option, you're going to be left with about 10.2 kilowatt hour storage. Okay. Or the fourth option is that you could propose the HVM 11 kilowatt hour. And the last option is that you could propose the HVM 13.8 kilowatt hour battery. So yeah, I really appreciate everybody's input on this question. Okay, I will leave the question open for another 15 to 20 seconds. Okay, we'll be closing the poll in 5 seconds, so please do share your answer. Okay, I'd like to share the results. Okay, so we can see that the majority of today's audience would install a HVS 5.1 kilowatt hour battery, followed by a good portion of the audience who thinks that an HVM 13.8 kilowatt hour battery would make more sense, followed by a good portion of the audience who also think the HVS 7.7 kilowatt hours would make a good compatibility. Okay, thanks for sharing your answers. Okay, Cyprian, if you could please take over.
Okay, Mo. Okay, thanks a lot, Mo, for your wonderful presentation. I will be taking over from this point, and I believe you can all see my screen right now. So I will be taking on the installation and commissioning of the Fronius GEN24 full backup. So starting off with the installation, just to give you a summary that the full backup mode is 100% capable of providing maximum independence during grid outage. And by so saying, it means that it can provide real three-phase backup power, unlike some other products that are not able to do so. So you'll be seeing details of this in the subsequent slides. Of course, the changeover or switchover is automatic. It's approximately less than 60 seconds. And of course, to achieve this, battery is required. And in this case, the BYD premium batteries, HVM and HVS. My colleague in this presentation, Ivan, will be shedding more light on this. So just to keep you abreast with the connection, cable connections, just a brief summary, as you can see. So we have the DC point where you connect your PV cables, and then of course your battery cables. You have the pilot, which is integrated with the communication modules for connection to the smart meter and the battery box, as we will see subsequently. And then of course the AC connection point. Of course we have the PV point, but this will be a topic of discussion in subsequent webinar. But today we are discussing full backup of the Gen24 Plus, Cyber Gen24 Plus inverter. So going on, we now have an SLD single line diagram of how this looks like in full backup mode. So basically, when there's grid outage, of course, this there will be no longer supply from the grid, and most importantly, this backup switch swings into play because it will have to disconnect the connection between the AC bus bar, connection between the inverter and the grid, so as to allow the inverter to build up its grid and then supply load from the battery, as we will see in the following illustration. As you can see, so once there's a grid outage, of course, the inverter takes over and then supplies the load from the battery, as we can see. So that's how the full backup functions. So to shed more light on this and how this actually takes place, I will, just to give us a brief info on what happens necessarily in terms of technical data. In terms of nominal power, it ranges between 3 to 6.2 kVA, depending on the power class. As we all know, for the Primo Gen24, it ranges between 3, 4.5, and up to 6 power classes. And then for the Simo Gen24 Plus, it ranges from 6, 8, and up to 10 kilowatts. So with this, nominal power per phase ranges for the Primo, as said earlier, 3 to 6.2 kVA, and then for the Simo, it ranges from, of course, up to 12.1 kVA for up to 5 seconds to handle transient loads, and then power per phase is 3 to 6 for the Primo, and then of course up to 4.1 kilowatts up to 5 seconds to handle transient surges. So, of course, the maximum discharge current for both cases is 22 amps. So just to give you throw more light on that. So basically, in order to get to calculate the discharging power, all you need to do is to multiply the current by the voltage, the nominal voltage, to now get your approximate value of power. So as you can see in this case for 3-phase, 8.8 or approximately 9 kilowatts. Good. So shedding more light on that, it's great to see that for the charging, both charging and discharging power with the Fronius 3-phase, that is Fronius Simo, you can get up to 9 kilowatts even during the outage, which is a very, very, I would say, a phenomenal feat, because you hardly get this in other products. So in both cases, both for the HVS and the HVM battery, you can get up to 9 kilowatts even during a grid outage. So for the BYD storage combination, my colleague Mohammed Sidat has already shed light on that. So this is just to give you a summary of combination matrix for the BYD battery box premium HVS and HVM combinations and how they are likely to be connected. So we will be sending out this presentation to all attendees. So you're going to get this presentation for you to easily go through subsequently. Good. So this is to shed more light on how the parallel operation occurs, how the backup comes into play. And of course, I got answering some of your questions before I started presenting. I got some questions asking about the operation of the backup and why it takes up to about 60 seconds for it to actuate. So this is the main reason why this is done. Of course, my colleague Mohammed has also told you or made mention of the reason why this is so. So this is just to give us a detailed look into how this happens. So let's take in the case where we have grid present and we have all connected our backup or backup switch or full backup disconnection switch. This is how the orientation looks like. Once there is power outage, this is what now happens, because the backup switch engages and then disconnects the load from the grid, as you can see in this case. Go one step backward for you to see how it was. So there is a connection to the load via the contactors K1 and K2. So in the event of grid outage, and before I go further, mind you, K1 and K2 are supplementary contactors which function in active redundancy mode, as you can see. So it sources its the coil is actually sourced from the grid, as you can see. So once the grid goes off, definitely K1 and K2 of course goes off. And once they do, K3 comes into play and serves as the feedback input to the output ports, as you can see in this case. The normally open contacts of K1 and K2 now becomes closed and then serves the input with 12 volts feedback voltage. Now, once the inverter sees this, it now raises its output frequency or AC frequency to 53 Hz, thereby enabling it to function on an isolated mode. So that is why, as Mo mentioned earlier, even if you have an AC coupled setup with the Gen24 inverter, it of course isolates the snap inverter and then functions in isolation because of this increase in frequency. So in order to make sure that there isn't any negative feedback or overlap of power due to time or transient failure, it is necessary to ensure that these disconnections and connections takes place before you can now have power being supplied to the load via the batteries. So these are all safety measures taken by Fronius to ensure that there isn't any negative feedback and malfunction. So I believe I have addressed this and answered the question that was put forward in this regard. Okay. So going forward, in order to make things easy, the NTech, which is a company, have come forward with the switch over box, which can be used in this case to meet all the requirements of the disconnection switch box. And of course, they can be contacted at the website www.mtech.eu. So you can get this MTech box supplied by Fronius, which comes with a 3-pole contactors, and of course with changeable relays and fuse connections from the Fronius GEN24 Plus. So that's for the power connection. Now talking about the communication connections between the GEN24 Plus and the BYD. Of course, we have modbus terminals. So for the pilot, as contrary to what we have in the snap inverter, we have two, in this case, two modbus terminals or ports, as we can see. And please ensure that these modbus switches are turned on. In order to make this clear, I'm going to see if I can zoom in a bit. Great. As we can see here, we can see that we have two modbus port switches. They are here, MB0 and MB1. So MB0 basically stands for modbus 0 and then modbus 1. So please ensure that the switches are on position 1. Ensure that the switches are on position 1, depending on the modbus you want to use for any respective reason or any respective function. So because if it is not, you wouldn't have any communication between either the BYD battery box or the smart meter. Integrated in this switch, in this IP switch, is a 120 ohms resistor. So this actually completes the connection, the communication connection between the pilot, which is a communication gateway for the inverter, and either the battery box or the smart meter. So to ensure that this switch is on position 1. So we have a diagrammatic representation of how they look like. So we have MO positive and MO negative. So this can also stand for D plus or D minus, depending on how you understand it as an installer. So as you can see in this case, it's D plus and D minus. And then we have M1 plus and M12, which is the other or the second modbus terminal. And then of course your 12-volt supply, ground, and ensure that your shields are appropriately connected. Good. I mentioned that it's supposed to be connected to the smart meter because that is your means of getting a wholesome view of your connection. So please ensure that your smart meter is appropriately and correctly connected. So for the smart meter connections, it's on terminal 8, 9, and 10, which represents MO plus, MO negative, and of course ground respectively. Please ensure that your shield is connected appropriately. And then to complete the communication gateway for the smart meter, all you need to do is to loop terminal 7 to 9. By doing this, you automatically activate the 120 ohms termination system. So this is, of course, only possible for the new smart meter, the new Fronius smart meter TS. For the older smart meters, you would have to physically connect 120 ohms resistor across the communication terminals. So please take note of this. Ensure that you use a twisted cable of Cat 5 and above. Good. So, of course, just a roundup of the needed switchover components. Because you need 6-amp circuit breaker, make and break relay, of course, the Fronius smart meter, and then your K1, K2 mains contactor. Good. So that was for the installation. Now let's talk about the commissioning. Of course, just to give you a roundup, it takes a good installation to have a successful commissioning. So ensure that your installations are correctly done. And once that is done, you only need to go through 3 easy steps for the commissioning. And this is made possible via our new app that was launched a couple of months ago, which is the Fronius Solar Start app. And these 3 easy steps includes connecting your product to the network, of course, imputing the product specification, and then, of course, connecting to SolarWeb. Once this is done via Fronius Solar Start, you can now have access to the device configuration, and then you can now effectively activate the full backup mode, as can be seen in this screenshot. So once you're done with the device configuration, you can now proceed to now activate the full backup power using this pin here. Once you click on it, you select your full backup mode, because here you have the option of TV point mode and then full backup mode. So since we're talking about we're activating full backup mode, you now have to select full backup mode, select your nominal voltage, and then continue. And if you have to do any energy management, you can, of course, use any of these available pins to activate your energy management pins. Good. So once that is done, you can now add your battery in. As you can see, you can add your smart meter, add your PV generator, and of course, add your BYD battery box premium, either HVS or HVM. So once that is done, you can, of course, have a look at your system through the Fronius SolarWeb. As you can see in the screenshot, it gives you a full and wholesome view of your system. In terms of here you can get your analysis, energy balance, get reports, and of course, all the necessary settings. And of course, you can also have remote updates done via this app. And just to give us a summary, you can have a very good view of what your system is doing, battery, state of charge, power consumed, power from any of the attached accessories like the Home Pilot, how much power is being, at what rate your battery is being discharged, and of course, temperature of your Home Pilot, as mentioned earlier. So you can have a wholesome view of your system once you go through this 3 basic steps in the commissioning of the GEN24 Plus inverter and the BYD battery. So that brings me to the end of my part of the presentation. I will now be handing over to Evan, who will be presenting the BYD part of the presentation. So I will be handing over to you now. You can see the prompt now. Ivan, you can now continue from here.
Hi everyone, my name is Ivan Holsworth. I'm the Technical Support Manager for AfriPlus Energy, and AfriPlus Energy is the official service partner for BYD batteries in the Southern African region. Firstly, I'd like to thank Fronius for offering us the opportunity to present on their webinar, and thank you to all the presenters who've come before me. There's going to be a little bit of repetition on some of the subjects, so I'm going to jump right in. And we're going to be talking mostly about the HVS batteries today, but I'm also going to touch on a little bit of the other premium batteries that are available. So here we have the new BYD premium range. On our left is the what battery we're going to be talking most about today, which is the HVS battery. We haven't decided to bring in the HVM battery, and I'll explain why later. The HVS battery is a modular tower design, and each module is 2.5 kilowatt hours about. And the HVM is similar. Next, we have the LVS, which is also a tower design, 4 kilowatt hours per module, but it's a low voltage battery. Next, we've got the LVL, which is a 15.4 kilowatt hour battery. It's an IP21 battery, and both towers are IP55. And next, we've got our commercial high voltage battery range. Here's a quick example of a low voltage battery with Victron battery inverters and a Fronius grid tie inverter. Now we're going to come to the battery we're going to talk about most today, the HVS battery. It's a high voltage battery system, and it's scalable from 5.1 kilowatts to 38.4 kilowatt hours. It's a LFP, lithium iron phosphate battery. It's very safe. It's the same cells that are used in these batteries are used in BYD cars. BYD is one of the leading manufacturers of electric vehicles in the globe, and the same cells that are used in those cars are used in these batteries. So they're designed for vehicle safety standards, which is really great news in terms of peace of mind. These batteries are capable of backup and ESS functionality, and because they're a modular tower design, they have no dip switches or no internal wiring that you need to adjust. And another nice thing is you can extend the batteries at any time. Here we've got the BYD HVS battery data sheets. So each module is about 40 kilograms, and it weighs it has 2.56 kilowatt hours of energy. It's fairly easy for one person to move and install, making it very nice and easy to install with one person. Here we've got our various options of towers. We've got HVS 5.1 kilowatt hours, 7.7 kilowatt hours, 10.2, and 12.8. I'll cover the compatibility of which towers with which Gen24s in further slides. So the other interesting thing to know about high voltage battery systems is the relation of current and voltage. So most installers are very familiar with your low voltage batteries. They're all about 48 volts, 51.2. And as you add more batteries, your current goes up, but your voltage stays the same. It's always going to be 48 volts. So with regards to each tower, on each tower, each module you add, your voltage goes up, but your current stays the same. I'm going to cover this more in further slides. And here we can see the footprint of the battery. It's about 600 wide and about 300 deep. And here you can see 12.8 kilowatts is really a nice amount of energy in a nice small footprint. And the other nice thing is they do look very nice. They look very elegant in any installation that needs to be presented. So here we've got the main difference between low voltage and high voltage batteries. I'd like to cover this a little more because it gives people some idea of how to handle high voltage batteries if they've never dealt with them before. So I'm going to compare them to our LVS batteries. LVS is also a tower design where you've got modules you put in a tower. So here we've got the different towers. You have 4, 8, 12, and 16. And that's a tower of 1, 2, 3, and 4 modules respectively. And here we can see as you put each module on, your voltage of your bank stays the same, but your maximum, the current that you can get out of it goes up, and the energy that goes up. So that's very typical of your low voltage batteries. However, with your high voltage batteries, it's very typical of high voltage batteries. In each tower or string, you have your modules. Our minimum number of modules is 2, and it goes up to 5. As you add each module, your voltage goes up, but the maximum current that you can get out of the battery stays the same. It's almost the inverse of your low voltage batteries. So it's just something to remember, that the current that you can get out of one tower will always remain the same at 25 amps. If you have 2 towers in parallel, then it'll be 50 amps that you can get out of your battery bank. And if you have 3 towers in parallel, it'll be 75 amps. But for each tower, you'll always only get 25 amps maximum out of the tower. With regards to how to familiarize yourself with high voltage batteries, I'd just like to compare them to something that's very similar, which is your photovoltaic solar panels. So here we've got a comparison between a high voltage battery and a photovoltaics. And here we can see the voltage of your photovoltaics. You typically have anywhere between 100 and 1,000 volts. And your BYD HVS batteries are between 200 and about 600 at maximum. The max is 500 nominal, but there is sometimes where it goes up to 550. So your voltages are fairly similar. With regards to current, your current on your PV strings is typically between 0 and 12 amps, and your current on your BYD HVS tower is anywhere between 0 and 25. They are fairly similar. It's also quite a lot of similarity in your wire sizes that you use. Your solar strings typically use 4 to 6 solar cable, and for your HVS, you can also use between 4 and 10 square millimeters. For your HVS, because it's only rated at 25 amps, and your Gen24 inverters are also only got 22 amps on the battery input, you can use, you wouldn't need to go above 6 square cable. Also, we'd recommend when using cable not to use your house wire, because your house wire typically is only rated about 600 volts. If you use your solar cable, it's typically double insulated and more suitable to the application. With regards to your short circuit current, this is the main difference between your photovoltaic cells and your BYD batteries. Your short circuit current on your PV panels is between 12 and 14 amps, and please don't short circuit your batteries. When the battery turns on, it does a quick self-check, and it checks if there's any shorts in the system, and it won't turn on if it detects any shorts. But if there is a short while it's operating, it will damage the battery. And the nominal voltage, unfortunately, is incorrect there. I'll change that before the slide goes out. So here we've got the tower design, and we've got an LED/power button, and there's a flashing LED in there that really quickly and easily shows that if there are any errors, and it's very easy to read and see what your errors are. And with regards to your installation, it's electrical Lego. So you've got your base and your towers that go on top. Very quick and easy locking screws, and all of your connections happen in this small little area over there, making it very quick and easy to install. And your box is IP55, giving a lot of flexibility where you can install it. And here's some common properties of the new BYD Premium range. Your towers are all IP55. Your operating temperature is very good. It's from -10 to +50, and your limiting of your charging and discharging only happens at +5 degrees. It's a very small limit at +5, and if it goes below 0, it starts to limit a bit more. It has got one of the widest operating temperatures of lithium batteries on the market. And your round trip efficiency is very good, and it comes with a 10-year warranty. Also, please refer to your inverter compatibility lists with regards to installing the batteries. I'm going to touch on that a little bit more in future slides. Here we've got the size of your battery backup systems. Here we've got an example of your backup, and if you draw more loads than your battery can supply in backup, your system will turn off. So it's very important to keep in mind when planning your backup systems to please ensure that when you plan your backup system, to make sure that the amount of energy your battery can supply is more than what your loads are going to draw. Because if your loads draw more power than your battery can supply, the system will unfortunately turn off. And here we've got the compatibility. So this is more voltage compatibility. So with regards to your CMO GEN24 Plus, these towers are compatible. Your HVS 5.1, your HVS 7.7, and your HVS 10.2. And with regards to your Primo GEN24 Plus, you can only use the HVS 5.1 and 7.7. If you do require more energy in your batteries, you can parallel towers. I do believe this question has been asked a couple of times, so I'd just like to address it here. The reason we haven't brought in the reason the HVM isn't being brought in is because the HVM battery is very similar to the HVS. It's typically designed for your larger storage applications, and its maximum current is 50 amps, and the maximum current on your HVS is 25. So, and your maximum current on your inverter is 22. With regards to your backup, if you wanted 10 kilowatts of backup, you'd actually need 20 kilowatt hours of HVM battery to supply that load. So your HVS can do that. If you need 10 kilowatts of backup, you can use 10 kilowatt hours of HVS battery, and you can parallel two towers. So your HVS can supply your medium scale, your small scale installations, and your medium scale installations. Your HVM can only supply your medium scale, and it can't supply your small scale very easily. So that's the reason there's only the HVS available in the Southern African region at the moment. And here we can see the maximum battery current is 22 amps, and this integrates very well with the HVS, which is a maximum battery current of 25. And here we can see the Primo and CMO. And here we've got the minimum energy in the HVS battery bank which you need to achieve full backup power. So for instance, if you wanted a full 3 kilowatts of you'd need a minimum of 5.1, but 5.1 is the minimum size of our tower as it is. And then for your Primo 6, if you needed 6 kilowatts of backup, you would need 7.7 kilowatt hours of HVS battery. And a similar scenario here with your CMO, where you'd always need enough battery to supply your backup loads. And the batteries are 1C, so essentially, if it's a 7.7 kilowatt hour battery, you can get 7.7 kilowatts out of that battery at any point in time. With regards to your installing, so your HVS and your HVM always are the same footprint and same box. So it's very important to check that you're not mixing modules. Only the HVS is really available in the Southern African region, so it's very unlikely to get mixed modules, but it's always very important to just check. And when you are paralleling towers, it's very important to make sure your towers have the same number of modules, because the voltage in your tower is dependent on the number of modules in it. So for instance, if you've got a tower of 4 modules, it'll be about 400 volts. So it would be difficult to put a battery of 300 volts in parallel with that. You'd have to have the same voltage on your towers. So it is very, very important to have the same number of modules in each tower when paralleling. With regards to your installations, here's a quick rundown of how to install. Your battery tower is typically installed near a wall, and it's very much designed like Lego. So the first thing to do is to take your module apart. This is the BCU, and what happens is it comes in 2 parts, your base and your top box. And so when you put your base down, it's important to put it down and make sure it's level. And then when attaching your modules, they're stacked pretty much like Lego. They're giant Lego blocks. electrical they go. Then it's important to mount your top box to the wall, just to ensure that your battery doesn't tip over and is quite secure. Here we've got the connection area. All the connections happen to your inverter happen in that area, and on the other side you've got your breaker, that side of the top box. And here's just some quick extracts of the installation of the quick install guide. Fronius has got a very easy to read quick install guide on how to connect the inverter to the batteries. Always make sure, please, that your inverter is off when you are connecting your batteries. And then here we've got your connections of your battery cables. Always please make sure that your battery cables are connected in the correct connector. And here we've got the communications cables. It's always important to make sure your communications are in order, otherwise the system will not turn on. Here we've got the Fronius side, and on the BYD side, we do prefer using the wire connector rather than the RJ45 connectors. It seems to work far more reliably. With regards to your commissioning, that's another slightly different difference between your normal batteries and the premium batteries. Your premium batteries need to be commissioned before they will function. So they can be very easily commissioned with an app downloadable on your Google Play or your Apple App Store. So a quick summary of the steps is you'd connect to the internet, you'd download the new firmware, you'd connect to the Wi-Fi of your battery, you would then upgrade the firmware of the battery, and it would typically take about 10 to 15 minutes to upgrade and to let all the upgrades happen in the battery, and then after which your battery would be functional. Here's a few examples of Fronius BYD's combos, and here you can see your Gen24 and your BYD HVS battery, and this is installed outside. And because the battery and the inverter are both got a high IP rating, I do believe the inverter is IP66 and the battery is IP55. It leads to a lot of flexibility to where you can install, but please do install that, ensure that it's under a cover and it's not exposed to the elements. And here we've got a quick picture of the Fronius and the HVS battery. So a quick explanation of who AfriPlus is. We're the official service partner for BYD in the Southern African region, and our goals are to provide quality technical support, battery training to installers, and to service warranties. And you're welcome to contact us. Everyone will be getting a copy of these slides, so the links will be in the slides. And there's also some frequently asked questions and web links to all of our links. And some of the questions that are regularly asked is, why is BYD launching a new generation of products? That's to keep up with the times. It's really time to launch new and more technical batteries. And BYD's got something for everyone in the new BYD premium range that's applicable to almost all battery applications. With regards to where you can get your new BYD premium batteries, please get in touch with your wholesaler. And if you have any troubles of finding a wholesaler to get in touch with, please contact us and we'll be able to put you in touch with a wholesaler who can assist you. With regards to, it's a question I get asked a lot, can you get old generation batteries? Yes, you can. Please get in contact with your installer, or you can contact us directly if you can't get in touch with your installer or distributor. And what should you do if you've got any issues with your battery inverter system not working properly? The best thing to do is to first contact your installer, and if you have any issues, or then you're welcome to contact us directly. And yes, there will be more new BYD webinars coming up, so please stay tuned. Here's some web links. So if you'd like more information and where to watch YouTube videos. The HVM and the HVS installation guide are very similar because they are very similar batteries. And thank you very much for having me. If anyone has any questions, they're welcome to ask them in the question panel. And I'd like to hand over now back to Fronius. Thanks everyone for attending.
Thanks a lot, Ivan, for that wonderful presentation. And yeah, I believe our attendees got lots and lots of information with regards to BYD Premium, HVS and HVM battery, and of course the orientation and connection procedures. At this point, I would want to launch a poll. Okay, yeah, I believe the poll is open now. So with all the information you've gotten from this presentation, will you now make a change from low voltage to high voltage PV storage systems? So it's basically a yes or a no. Yeah, because I believe Ivan really addressed on that point, giving you the main difference between high voltage storage systems and low voltage storage systems, the way they work in relation to voltage and current. So we've seen it, and then yeah, so it's time to make that decision. So will you make the change from low voltage to high voltage PV storage systems? I will be turning off the poll in about 10 seconds to now give us our responses. Okay, so I'm collecting your polls and I'm going to share them right now. So I'm sharing the polls now, poll results now. As you can see, a whopping 95% said yes, and then 5% said no. Yeah, so that's understandable. We've seen the main difference between low voltage storage systems and high voltage storage systems. So it now depends on our, first of all, the client, the choices might appear to hold sway or hold priority, but then as an installer, you also have the responsibility to educate the client on the features and characteristics of either the low voltage and high voltage, and then this would, of course, enable the client to make an informed decision in this regard. So thanks a lot for responding, and then, of course, giving your answers to our poll questions. Good. So going forward, I'd like to give us more information. Just to make us acquainted with the regions we cover, our colleague who is not in this presentation today, David Mwangi, covers much of East Africa. He is based in Nairobi, Kenya. As you can see, the regions he covered, colored in red. And then Mohammed Stida covers Southern Africa, as we can see also, with all the countries listed. And then myself, I cover, for now, the English-speaking West African countries, as we can also see in this case. So if you have any service case or any inquiry, please contact your respective technical sales advisor. Good. So for further more information, you can have access to a compendium of all the webinars that we have hosted on our channel through this link. So if in case you have or in doubt of any topic at all, or you need more information on any topic at all we have covered so far, you can have access to the webinars using this link. Of course, there are lots and lots of how-to and installation videos on our general YouTube channel, where you can have access to all our webinar recordings. Furthermore, you can contact Fronius Energy team with respect to trainings, after sales service, and technical questions. More precisely, you can, of course, as earlier said, contact your respective technical sales advisor, Mohammed Sidat, myself, Cyprian Okolo, or David Mwangi. of course, rest assured that we will be more than happy to attend to you. So at this point, we've come to the end of the presentation today. I'd like to say a big thank you to